All right. And so thank you once again for being part of day 3 of our evening session of InfoSource C Coding Bootcamp. Yesterday we had a good time. We were able to write our first code, Hello World. My name is so, and I am a proud programmer, or I'm proud to be programming. And so I want to believe that almost all, because I want to give some few minuses to it. Maybe some people weren't able to achieve the results, but not to worry, we'll still get it done today. We can only get better day by day. So, and yesterday I remembered there were some questions that were being asked, and so why hash include, why int main, why this, why that, and so today and subsequent days promises to be sessions that would enlighten us more about why we have all of those things and why they are written the way they are written. And so if it's your joy as it is mine as well, let's quickly zoom into Professor so that he will take us further and help us to demystify all the things about coding that have been so mind-boggling and all that. Professor, you're looking great. Please take over.
Thank you so much, Mr. Dela Peter. And it's true, we are here to demystify programming. If programming looks daunting to you, if it looks intimidating to you, in this bootcamp, we are going to deal with programming. After this bootcamp, you are going to see yourself as someone who really understands code. Maybe right now it's hard for you to look at code and make sense of it. But after this bootcamp, you can understand code, you can read code, you can write code, and when you go through any code, you understand what it is doing and you can modify code. I want to thank you for joining me. Today is going to be a wonderful time. Today we are going to have our very first quiz. And so I'm going to share a link in the chat. Once you receive the link, click on it and it is going to take you right into the quiz and you submit your answers. The quiz will show on your phone or on your laptop, whichever device you would like to use. Just click on the link and you will see the questions. Immediately you see the questions, just submit your answers. If your chat is not working and if you cannot see the link in the chat, we will share the link in WhatsApp as well. So I'll ask if anyone has access to share the link on WhatsApp for me. And also, if the link is not working for you, that means when you click on it and it's not working, just copy the link and paste it in your browser and submit your answers. I'm going to share my screen and we are going to see how the questions look like. Make sure you participate in this. Everyone is part of it. And at the end of the day, we will keep all the results and they will all add up to your performance. Remember, this is a real course and you are going to be certified. So take everything seriously, get involved, because in this bootcamp, you are going to fall in love with programming. Question 1, it says that computers do not really understand C++ code. I take it again. It says computers do not really understand C++ code. A, is it true? B, is it false? C, if you are not sure, you choose C. But this is an interesting question. The answers come in. I can see the answers rolling in. And while I wait for the answers, you know what? Let me take you through my slides and let's do some amazing things right now. We are a quick recap of yesterday's lesson. Today is day 3, and we are going to delve into what is referred to as low-level versus high-level languages. When you hear about programming, you hear low-level programming languages, high-level programming languages. In the next few days, we want to set the foundation for programming itself before we delve into C++ itself, because until you programming, C++ may enough for you. So we want to deal with the basics of programming. So today we are talking about low-level languages, high-level languages. The next day we'll be looking at compiling and other things. So submit your answers. Let me give you a quick recap of yesterday's lesson. And yesterday we looked at what computer programming is. So the question is, what is computer programming? Maybe you've joined this boot camp, you don't know what is really going on. You don't know what C++ even is. All we are saying is that this boot camp is about computer programming. So what is computer programming? Computer programming is the process of creating computer software. The process of creating computer software. Now, there are sophisticated definitions for computer programming, but over here, I want everything to be very basic so that everyone will understand. So in a nutshell, programming, computer programming is about creating software using a computer programming language. Any software you use, know that you are learning creates software where you conversation and the person to know I'm a programmer. And the way he asked the question, I thought he was a programmer. So I asked him, which languages or which language do you program in? Because anytime you talk about programming, the first question or the next question is going to be the language you program in. And so he made a terrible mistake by mentioning English, French, and other human languages. And I realized that he had no clue about computer programming. And so when we talk about computer programming, we need to deal with the languages. It is a language we use. Programming language is a computer language that is used by computer programmers. Most of the time, if we want to increment a value, we use plus. Hello.
Hello, Professor.
Hello. Is my line breaking?
Yeah, sorry, we are losing you small. So the line is quite...
Audio? Is it the audio or the video?
Both of them. So perhaps we might want to take the video off for now and see. Because both were breaking.
All right, let me deal with that. I apologize. All right. Thank you for letting me know. All right, so let me just turn off the camera, and that may save some of the bandwidth. I'm fully connected to a high-speed internet, but I think there is an issue. So, all right. All right, so all I said was that we have a very powerful programming language called C. Even today, C is still amazing. But then C has some limitations. And so someone, an advanced developer, took C and improved upon it. He made C better, and he called it C++. Now, in programming, when you see plus, it makes a lot of sense. Anything plus means you are incrementing the value. So as we are learning coding, you realize that a time will come, we'll be adding plus to variables. So we can say I plus or X plus, and anytime you write plus, it means add another value or increment the value of a variable. So C++ means C has been incremented. We also have a language called C#, and we have a family of languages under C, or we call them the C programming languages. Once you learn any of them, the rest are very similar. We have Java, we have PHP, we have Python, we have HTML, we have CSS, JavaScript, we have SQL, and we have Ruby. These are all programming languages. So when we ask of programming languages, don't go and mention English and French and Spanish. Mention computer languages, and that is what you see. Now, we learned that we use programming languages to communicate with computers. I believe you remember, programmers use programming languages to communicate with computers. Let's get back to our quiz, and the quiz says that computers do not really understand C++ code. Please, I believe you can all hear me. Brother Peddy, is it okay now?
Very loud and clear, boss.
Beautiful, beautiful. Computers do not really understand C++ code. Is it true? Is it false, or you are not sure? Please let the answers come in. Let's see how we are doing. And whoa, we have 45% saying it is true. Computers do not really understand C++ code. And we have 55% saying it is false. C++ is a programming language, and computers understand C++. If computers do not understand C++, why in the world are we here learning C++, thinking we are going to communicate with computers? And so 55% are saying it is false. Now, I want to call one person to explain to me why you think it is false. Then I'll call one person to tell me why it is true that computers do not really understand C++. And after that, I will give you my answer. So if you selected false, please raise your hand and let me call you, just one person, and I will call you for you to tell me why it is false. I'll call you. Okay, I have Richard. Please unmute yourself, Brother Richard, and tell us. Okay, so I'm getting more hands, but Richard came first. Richard, unmute yourself. Brother Peddy, can you enable him for me?
Yes, Richard is enabled. Please unmute yourself, Richard.
Okay, Richard, go ahead.
Can you hear me?
Yes, we can hear you.
Good. So I think that it is false. It is false because the computer languages are what we are talking about. It is the languages of the computer is the C++, it is PHP, it is the Java, and then the others. So of course it is not true that the computer does not understand the C++ code. It is in fact its own language, so it honestly understands it. That's what I think.
Thank you so much. Thank you so much. Thank you so much. All right, so I'm done with the false group. Someone just added to false upon hearing the explanation from Brother Richard. We are here to learn, okay? And every answer is right. Now, when you get an answer and you think the answer, or we tell you that the answer is not right, then just find out the right answer and get the explanation. So let me take from the true group. If you selected true, raise your hand now. I'm just calling one person. If you selected true, okay. All right, so I can see, I wanted to call you Sir 858, but I can't see your name, so I'm not going to call you. I want to call Peter. Peter, go ahead and tell us why it is true.
Okay, good evening, everyone. I think it is true because C++ code without its compiler or something, an additional software or something. Yeah, that is what I think.
Okay.
Hello.
Okay. All right, so we are losing the true group. Let me take one more. I see Sule Montari. Hey, it's not Sule Montari. I see Montari Dauda. Please enable Mr. Montari and let him tell us why it is true. If you're in the true group, then tell us. If you're not in the true group, I'm done with the false group. So if you're in the true group, tell us why it is true. All right, Montari, please go ahead.
Good evening to everyone.
Yes, good evening.
Professor, I actually chose for true. I raised my hands, but I wasn't called to answer for the false.
Okay. All right. So why do you think it's false, please? Just go ahead.
It's false because I think the C++ is the only code the computer understands, and it's the only code the programmer uses to communicate with the computer.
Our answer is very clear, and your answer is very understandable. But then the correct answer is A, and A is true. Computers do not really understand C++. Really? Why are we saying C++? Why are we learning C++ thinking we want to communicate with computers? Now, as we advance in our knowledge of computing, we are going to understand that do not understand Java, Python, C++, CSS, JavaScript. All these languages, computers do not understand them. So why do we use to communicate with computers? We use them because they are languages that have been made available to humans for humans to write their instructions. But then, before the instructions will be understood by the computer, the instructions are changed into computer language. Are you saying C++ is not a computer language? It is, but it is what we call a high-level language. Computers actually understand only one language. That language is called machine code, also called jet code, and it's also called binary. Just one language. That one language is zeros and ones. Apart from that, computers do not understand any other language. And so when you write any code in any high-level language, that code needs to go through another system. That system is called a compiler or a translator. And that system will convert your C++ into machine code before the computer can understand. CPU knows nothing about C++. Your CPU knows nothing about Java or Python. Your CPU only understands ones and zeros and can only process ones and zeros. So your C++ code will become ones and zeros before it will be understood. So that is going to be our main lesson for today, because in the early days of computing, programmers were writing code in ones and zeros. They were writing software in ones and zeros, but guess what? It was extremely difficult and it took a very long time to create software. And so we had some smart engineers who found a way of creating human understandable languages. And those human understandable languages were written and then passed through something like a dictionary. We call those things translators. And the translators will spit out ones and zeros after interpreting what the humans wrote. So that is how programming looked like, and we will understand that today. Let's look at the next question. It says that high-level programming languages are easier for computers to understand than low-level languages. So please lock in your answers right now. High-level languages are easier for computers to understand than low-level languages. send your answers now, and let's do this. I'll do my best to work within time. So let's just go ahead and continue. So all these languages, the computer does not know them. It is we humans that know these languages. And these languages were created by people. How did they create these languages? They created them by mapping groups of ones and zeros and representing those groups by words that humans can understand. So when we write our code in these languages, they go through another system and they are translated. Once they are translated, they become ones and zeros. So if you write C++, you are actually writing ones and zeros after it is compiled. Now, why we choose programming languages, we talked about that yesterday. We choose because of platform. Maybe we are building for Android, iOS, Windows, or desktop, web, or mobile. We choose because of platform, and we also choose because of the function of our software. We learned that C++ is a cross-platform programming language. You can use C++ to develop desktop applications, web applications, mobile applications for Android, iOS, macOS, Windows, Linux, GNOME, and any other operating system out there. All right, so we will delve into today's lesson, but before we get into today's lesson, if you have submitted your answer, if you have not submitted your answer, please submit your answer first. But if you have submitted your answer, I want you to type what you see on the screen in the chat. #include IOStream. We did that yesterday. Please, I want you to do it for me today. #include IOStream. Put that in the chat for me. If your chat is not working, go to WhatsApp, smash it in WhatsApp, and let's code. All right, so let me see the answers. It says that high-level languages are easier for computers to understand than low-level languages. Let's see how we did. And we had 20% saying it is true. High-level languages are easier for computers to understand than low-level languages. 70% are saying it is false. High-level languages cannot be easier, but low-level languages are easier. 10% are not sure, and the correct answer is B. High-level languages are easier for humans to understand, but computers understand low-level languages better than high-level languages. Please don't wait for me to tell the answer before you select yours, please. We are learning, so submit your answer. It's not going to affect you in any way. We just want you to participate. All right, so in programming, we are going to realize that we have a vertical bar. At the top of the bar, we have high-level languages. At the bottom of the bar, we have low-level languages. After the bottom, we have computer hardware, or we have the processor. Now, the low-level languages are actually languages that are closer to the processor. And so when you write code in the low-level language, if your code is in machine code, the processor understands immediately. But if it is not in machine code and it is in a mid-level language, you have to translate it before the CPU will understand. But even with that, it is easier for the system to understand than high-level languages. High-level languages do not make any sense to your computer unless they are translated. But high-level languages, like I said before, are at the top of the bar. And after the top of the bar, we have humans. At the bottom of the bar, we have the machine. So the high-level language is closer to humans, and it's easier for humans to understand. We'll talk more about that today. And so let's be fast. Over here, did you know that code powers the digital world? The digital world today is powered by code. Every website, smartphone app, computer program, calculator, even microwave relies on code in order to operate. This makes coders the architects and builders of the digital age. Coders are ruling the world. All the gadgets we use run on code. Do you know that even remote controller runs on code? There is code in the circuit board. And if you learn C++, you are learning to send instructions to machines like that. So programmers are actually the ones who are powering the digital age. This is myself. My name is Darlington Fadams, and I'm your instructor for this course. Let's move on to our motivational quote for today. It says that sometimes later becomes never. Sometimes later becomes never. So guess what? Just do it now. Maybe you want to learn C++ and you are saying, oh, let's do it later. This bootcamp, let me join the next year one. Next year I'll be ready. Maybe there's something you want to do, a project, a business, a course you want to pursue, whatever you want to do. Sometimes you just put it later. But you have to understand that there are certain things that if you don't do now, you may never be able to do. Sometimes later becomes never. So just do it now. If it is very important, do it now. 1 hour a day is good enough to invest in it. All right. Today's lesson is going to be about low level versus high level. This picture here gives you an idea of low level language. And over here at the bottom here, the picture here gives you an idea of high level language. Try reading the high level language and you realize that it makes sense. It's a little bit of English and mathematics. So you can see that if you can memorize the English words and you can understand how arithmetic works, you can actually be a programmer. But think of the ones and zeros. In the early days of computing, this was the only way people created software. But then people realized that it was extremely difficult. And so we will learn what happened. Programming languages are separated into two classes. So I understand from my guys who said C++ is a programming language. Yes, it is. But you have to understand that programming languages are separated into two categories. Programming languages are separated into two categories. The first category is what we call low-level languages, and the second category is what we call high-level languages. Low-level languages are languages that are closer to machine language and are easier for computers to understand. Low-level languages are languages closer to machine and are easier for computers, which are machines, to understand. High-level languages are languages that are closer to humans and are easier for humans to understand. In the early days of computing, we only had low-level languages, and engineers did all the code to write software in low-level languages. Today, almost nobody programs in low-level languages. Everyone uses high-level languages. Everyone writes code in high-level languages. In your university, you will hear of courses like C++ high-level programming language. Now, when you hear high-level programming language, don't think in your mind that you are learning a language that is advanced than any other language in the world. The high level doesn't mean it is so much better. And I'm not saying it is not, but I'm just trying to tell you that if you don't understand this, when you hear high level language, you may think you are learning a supreme language. That is not the interpretation at all. These languages are powerful and they are the ones we use today, but it simply means they are closer to humans and far from machine. But then low-level languages are actually closer to machine than high-level languages. Examples of low-level languages, we have two of them. The first one is what we call code. Machine code is the same as binary. Then we also have assembly language. Assembly language was the first English-like language that was created after machine code itself. But then it is also a low-level language. For example, if you want to write code to calculate 2 plus 3, you know 2 has to be written in 0, 0, 1, 0. That is what 2 is. Guess what? Even the plus, you have to write it in ones and zeros. So it will be 0, 1, 1, 0, 0, 1, 1, 1, 0, 1. That means plus. Then the 3 is 0, 0, 0, 0, 0, 1, 1. Now add. With assembly language, we use certain things we call mnemonics. So for example, you can use a mnemonic like add 2, 3. Just look at this, add 2, 3. Is it not easier than 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 1, 0, 1, 1, 0, 1, and then 0, 0, 0. So you can see that assembly language is easier, but then it is also at the bottom. Even though it is referred to as a low-level language, machine language needs to be translated before it will run on any machine. And so machine languages also have their translators. We'll talk about that. When it comes to high-level languages, which we use today, we have C++, we have Java, we have Python, we have C#, PHP, Ruby, JavaScript, and all of these are high-level languages. We are not saying they are not programming languages. We are actually saying that these are the languages we use for programming today. We don't even use low-level. But then we need to understand their status. And anytime we write code, our code needs to go through translators before our code will be recognized by machines. I believe this is clear enough. Again, we are setting the stage for programming before we delve into C++ itself. So over here, you have a picture of machine code and how it looks like. You can see 0, 1, 1, 0, 0, 0, 0, 0. And over here, this is a comment trying to tell us what this code stands for. So all the 0, 1, 1, 0, 0, 0 here, this is what it means. This one here, this is what it means. So in programming, we will learn about commenting. So you can write code and write comments beside them. Look at assembly language, how it looks like. You can just write the mnemonics here, like CMP space AX, 97. And this one means compare AX to 97. You see how easy assembly language is. But assembly language is also very difficult as compared to high-level languages. Today, we have very, 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 very few assembly language programmers. I was telling my students here in my school that in the world right now, we have just 10 people who can program in assembly language. And I told them jokingly that last year, Corona killed 7 of them. So now they are left with only 3. All right, that's just by the way. In the early days of computing, people had to write entire programs in machine code. Today, almost no one writes programs in machine code. As for this, you can be sure that no one writes program in machine code. This is how assembly language looks like. And it says that programming languages are used to define the set of instructions that are executed by CPU. The CPU only executes machine code that is in binary. Binary is the only language computers are capable of understanding. If a programming language is closer to machine code, then it is considered low level. So why do we call a program low level? It means, why do we call a programming language low level? It means it is closer to machine code. Low-level languages provide little or no abstraction from the hardware. That means when you write code, The code doesn't need to be translated. Let me explain it in simple terms. The difference between your code and what the hardware needs to understand is similar. Sometimes it has just little abstraction and sometimes no abstraction at all. High-level languages provide higher abstraction. Based on the levels of abstraction, they can be classified into two categories, low level versus high level. So actually the term came because of the levels of abstraction. With low level, there's no abstraction or very little abstraction. With high level, there is high abstraction. All right, now I'm going to educate you on something very important. After assembly language was around for some years. In 1957, the very first high-level language was created. The very first high-level language was created in 1957, and the language is called Formula Translation, aka Fortran. I'm sure you've seen or heard of Fortran. Maybe you didn't understand it. It stands for Formula Translation, and it was the very first high-level programming language that was created, and it was created in 1957. After that, in 59, we created COBOL. COBOL stands for Common Business-Oriented Language. So these two languages were the pioneers of high-level programming, and so I want you to type Fortran into bracket Formula Translation in your chat or on WhatsApp. Actually, put this on WhatsApp for me. Fortran into bracket Formula Translation. And I want you to understand that this was the very first high-level programming language. After that, we had languages like C, C++, and the rest. But Fortran was our main guy. After Fortran, we had COBOL, Common Business-Oriented Languages. So please put this in the chat for me. I want to inspect all of them. Post everything in the chat. Modern high-level programming languages include C++, Java, Python, and all that we've talked about. If computers do not really understand C++, why then do we write code in C++? C++ is a high-level programming language. All C++ instructions are converted or translated into machine code by a compiler before execution. So this answers the question we had in the quiz. So please upgrade your understanding right now. And this is what will make you a programmer. You are getting the technicalities, what happens behind the scenes. Keep this in your mind, and now change your understanding of computer programming and programming languages. Update yourself right now, and let's move on. I'm going to compare high-level languages to low-level languages in a minute. It says that low-level languages are considered machine-friendly. Watch this, machine-friendly. Low-level are machine-friendly. High-level are programmer-friendly or human-friendly. So I'm sure you've seen this. Low-level languages are challenging to learn and understand. High-level languages are easy to learn and understand. So it is easy to learn C++ than machine code, than assembly language. Low-level languages are very close. Low-level languages are very close to the hardware and help to write a program at the hardware level. High-level languages do not provide many facilities at the hardware level. Number 4, low-level languages are difficult to debug. When there are bugs in your code, to debug is difficult. But high-level languages are easy to debug. Low-level languages consume less memory, and high-level languages consume more memory in comparison. So this is the first understanding we need to have about programming, and I believe this makes sense to somebody. If you want to be a programmer, update your understanding. We are trying to give you some basics. We are not going to do a lot of theory, but we are just giving you the basics to set the foundation for computer programming. All right, I'm going to move to my second PC, and we are going to code right now. So we are going to do our coding, and today we are going to write something very simple that will help you. So please, if you are interested in learning programming, it has started. It has begun. Start understanding and start coding. I'm going to use Visual Studio Code again. So I have Visual Studio Code right here on my desktop. I'm going to open it and let's code. All right, so now that my Visual Studio Code is open, beautiful. I can see Fortran and COBOL. Please, if you have not submitted yours, please submit either in the chat or on WhatsApp. This particular one, I provide it on WhatsApp. So just put it on WhatsApp. Let the whole world know that you are learning programming. All right, so I'm going to click on File, and I'm going to click on New File. And again, when we come here, we select a language. So when you click on Select Language, you need to choose your language right here. And over here, you can see that I'm going to select my language. Watch this. We have a language called C. You can use Visual Studio Code to write code in C. C# is another language. This language is not called C#. It's called C#. Then we have C++. So I'm going to code in C++. I just select it, and I want to save my work before I start coding. So I go to File and Save, and I will choose where I want to save it. And let me actually come here and create a folder here called B3. Open to that folder, and I'm just going to call this file welcome.cpp. Simple, welcome.cpp. Welcome.cpp. Again, CPP is not a political party. It simply stands for C++. I didn't say you should name your file welcome.c++. I'm just saying the CPP stands for C++. So your file should be welcome.cpp. All right, let's go ahead and let's do this. The first code you write is this, hash include. Then you write your IO stream, hash include IO stream, and we are delving deeper. We are delving deeper, and we are going to understand that this hash include does something. I believe by tomorrow we'll get the full understanding. But this hash include is a command. Yesterday we posted it in our chat. It's a command, and it's a command telling your compiler that it should go and open this file. This is a header file. It's a header file. Tomorrow I'll talk about header files. This IO stream, even though you don't see any extension here, it is a file. And this file contains a lot of instructions. And the instructions within the IO stream are necessary for every C++ software. And so if you want to write C++ software, make sure you include the IO stream. There are just some few kinds you may not need the IO stream, but 98% of all programs will use the IO stream. Again, I want you to watch something here. I'm going to move to int main. Yesterday, I entered using namespace std. Today, I'm going to do without it for you to see. Now, this main is a function. So once I start the function, I open my curly braces, I hit enter, and I type return 0 here. Later, at this function, and so after writing your code, you need to return a value. And because it's an integer, the return type is integer, you need to return an integer. So you have to understand what integers are. So 0 is also an integer, so we return 0. And this is just the way we handle the main function. Now, anytime you see the curly braces open, you see a line here. Let me bring the curly brace down here so that you see the line clearly. What it means is that this is a body of the function, and every instruction within this function should be within this body. So over here, the instructions will come here. The first instruction I'm going to write is to tell my system to clear the screen. So I'm going to write CLS like we did yesterday. So system CLS here. And the next instruction here is that I'm going to create a variable. We'll be learning about variables pretty soon. So watch this. I'm going to create a variable. This is how I create a variable. The variable is actually this. The variable is name. But then we have this thing here. We call it a data type. We'll talk more about data types. And it is qualifying this variable. Right now, I think there's an error somewhere, and I'll tell you where the error is coming from. For now, let's continue and see. In C++, we write codes like cout, and cout does something interesting. By now, I'm sure you know what cout does. Anytime you write cout, we use cout to push a message to the screen. So here, after this left shift operator, in the quotes, I created a quote here, and then I type the message I want to push to the screen. So here I type welcome to C++ Coding Bootcamp. And I come here /n/n. And then over here, semicolon. All right, so I've written a very important instruction, and I use this cout to send that message. Cout means send a message to the screen. This operator here is what to push the message to cout. So this is a message that will show on the screen. Again, pay attention that because this message is going to the screen, it needs to be written in a friendly way, because you don't know whether it is a president who is going to see it, or it is your boss who is going to see it, or your father or your pastor or someone you respect who is going to see it. So anything going out needs to be dressed properly. So you realize that I typed it in the right way. The W welcome, I use capital W. I didn't start with small w. We don't start a sentence with small w. C++, I made a C capital in the right way. Coding Bootcamp, this is how I wrote it. And all of those are in quotes. Remember, anything in the quote is going out. If something is not in the quote, it means it's not going out. For example, this welcome.php, it is internal, so we didn't bring spaces or anything. But here, this message is going out. If you don't bring spaces, it's going to be like this, and it doesn't make sense to any reader. That's why I said you don't know who is going to read it, and so you need to format it the right way, because this is going out. Anything going out will not affect your code, but will be pushed out. That's why we have put them in quotation marks. All right, let me put in the next line. And the next line is saying, what is your name? Over here, I'm going to use code to receive information from the user. In C++, you can send information to the user on the screen, and you can also receive information. When you receive information, you need to store the information in your variable. So here I'm going to create a variable. I'm going to store this information in a variable which has already been created. The variable created here is name. So here I'm going to use this and type name here. What this simply means is that the question we ask the user is going to trigger an answer. Whatever answer the user puts in, we are going to collect the answer and store it here. So you can see that variables are storage locations. When you study computer architecture, you learn that we have registers, we have RAM, we have ROM, we have our hard drive, our flash drives, our SSDs, and they are all storage locations. Even our BIOS, which is a ROM. In programming, we have variables to store data. Before you can use your variable, you need to declare it. So I've declared a variable here, and right now I am storing information in. So whatever the user will type, I'll push it here, and this is how to do that. All right, I'm going to type one more line of code and we'll be done with today's coding. All right, so we have cout. Let me put #n, hi, and watch what I'm going to do here. If this makes sense to you, then you have moved to another level. Watch this. I want to send a message to the user, and watch how I'm doing it. I only wrote hi in this quotes. I came out, I used a left shift operator, and I typed name. Left shift operator again, comma, space. You are welcome to InfoSource C Coding Bootcamp. Then and semicolon, I'm done. What does this mean? This is simply saying hi. Anything in the quote will be exactly as it is. Then hi name. Why are we highing the name? Why didn't we type the name of the person? We didn't type the name of the person because we don't know the name of the person. We don't know who is about to use our software. But then we have instructed our software to collect the name and put it in a variable. So whatever name the user will enter will be stored in name. And so over here, when you say hi name, it means whatever is in name is what to show. Let me save my work and run it. And first of all, we will get some errors and we'll fix the errors. After fixing the errors, you realize that when we run our code, it's going to fail miserably. So if it had worked, I would have been so surprised. That's why did it work? Because I know it's not supposed to work. Let me run it again and tell you one of the reasons why it didn't work. Let me run it again. Very soon, we are going to get a deeper explanation to all of this. Now, I want someone to read what I have highlighted here. If you want to read for me, raise your hand and I'm going to call you. Just read it for me. Just read. Simple reading. Simple reading. All right. So I have Meridakon. So Meridakon, please unmute your mic and read what I've highlighted.
Good evening to everyone. It reads error. C out was not declared in this scope.
Excellent, excellent, excellent. So it says that error C out was not declared in this scope. Now, wait a minute. We write C out all the time. C out is always in C++. So why is it saying it doesn't understand? Right now, you can see that string is not colored. C out is not colored. C in is not colored. Even the NL, we have an NL. They are all not colored. They are all white. That means they are not the system cannot understand them. They are unknown. The reason why they are unknown is because they belong to a certain namespace. When you talk about namespace in C++, you are simply talking about like a family name. So if you use certain objects, you need to make sure you mention the namespace. If you don't mention the namespace, they will not be, the system will not recognize them. Let me give an example here, and I'm looking for two people with the same name. And right now I can see that we have two Ernests. I can see NS1, NS2. Now, if I just come into a room where these two people are seated and I say Ernest, I call Ernest, what do you think will happen? I think both of them will be confused because they will not know which of them I'm referring to. In C++, there are certain objects that once you just use them, C++ will not bother processing them because it doesn't understand, it is confused. Because this object has a namespace and you didn't use a namespace. And so if instead of calling Ernest, I actually add a family name. So the namespace is like the family Ernest belongs to. If I say Ernest Odai, then I am very, very clear and specific. And so Ernest Odai will be sure he's the one, and Ernest Peter will also be sure he is not the one. That is what happens if you don't declare the namespace. So watch what I'm going to do to see out. See out belongs to a namespace in C++ called std. And so to use a namespace, type the namespace and type colon. Once you do that, the namespace will be applied. Now you can see that the color has changed. It means now it can be recognized. This one is not recognized. I have to do the same thing. std colon, then you see that the color will change. cin, I'll do the same. std colon. Anywhere I see C out, I have to put std colon. Over here, I need to put std colon. I have another endl here, std colon. Now, all these objects, you can see I have, now you see the colors have changed. I have NL, I have C out, C in, even this string. It is now that it's going to work. You see the color has changed immediately. They all belong to a certain family. In C++, we don't use the word family. They all belong to a namespace. And the namespace is std. Declare the namespace, you realize that they will not be recognized. And so now that I have declared the namespace, let me run my code again, and you see that we will not have errors. So it's going to run, and you see that it's going to run beautifully. Welcome to C++ Coding Bootcamp. It's working. What is your name? Watch this. Darlington, enter. Hi, Darlington. You are welcome to InfoSource C++ Bootcamp. Okay, how did you know I'm Darlington? Let me CLS and run it again. Let me put another name. The same code. Let me put Michael. Hi, Michael. You are welcome to InfoSource C++ Coding Bootcamp. Remember, instead of we hard coding the name, we didn't hard code the name. We actually used a variable to hold the name. And we collected the name from the user. That means whatever the user will enter, it will be stored in our variable, and the variable will spit it out when it is bringing the last message. So that is what the variable did. Very soon we'll get into variables, and it's going to be wonderful. Now, in almost any program you write in C++, these objects you see here, you are going to use about 1,000 of them in any full software you develop. And so, do you want to type std colon every single time you need to use any of them? You can do without them. Watch this. If you want to do without them, it is acceptable, but you need to include something at the header level. So I'm doing without them because typing std every time makes me feel like there's an std around. Okay, so to avoid typing std every time, watch this. I can just come up here and type this. Watch this. Using namespace std. You see, when I put it at the top here, it will run through the whole code. You see that they will all be recognized immediately. The colors have changed immediately. Let me save, Control S, and run. And you can see that we are not going to get any error. And of course, there's not going to be any std that will infect us. So what is your name? I type my name, and boom, it's working. So now you understand why we use using namespace std. If you don't bring this line, you have to add std to all the objects here. We'll take them into details and we will learn what they actually do. But today we've learned that they belong to a namespace called std, and we can actually include them at the top here And that will save us from typing STD every time. And even if we use STD 1,000 times, we are not going to type STD again. If we use C out and C in and NL 1,000 times, we are not going to put STD in front of them. In our next lessons, we are going to delve into details and we are going to create our own namespace for you to understand that, wow, this namespace, we can actually create our own and use our own. So next time, let me give you a sneak peek into next lesson. We are going to learn using namespace InfoSource. Right now, there's no namespace called InfoSource, so it doesn't make sense. But we are going to create our own namespace, and we are going to use namespace InfoSource in our next lesson. If it's not tomorrow, maybe the next one after that. I want to thank you all for joining this class. Again, little by little, we are making progress, and everything will make sense to you. Just make up your mind that I'm going to follow everything. And if I don't understand anything, I'm going to ask questions. So please, if you have any question, raise your hand and let me give you an answer. If something is confusing, raise your hand and I'll call you and you tell us what is confusing you. But then again, in the next few days, we are just laying the foundation for computer programming. Today, we have heard about high-level and low-level languages, how they are or what they are. All right, so let's unmute Mary Darko and let her ask her question, and let's code. All right, so Mary.
Yes, Professor, good evening.
Good evening, Madam.
Professor, good evening.
Good evening.
I think when I run your code that you just taught us, I had an error. My error page was telling me that if it's a long one, they say if the $sign and some question mark, and then they said the C minge W bean slash LIB slash, it's a long one. I don't know why I got that error.
Can we see your screen right now? Can you share your screen?
Now I'm using my laptop. I'm using the laptop for the coding.
Yes. And the Teams is on your phone, eh?
Yes, please.
So can you turn on your camera and let it face the laptop so that we can see? If you are not ready today, you can
my
do
phone.
That
okay.
If you turn on the camera, you can.
Okay, so that it can face the laptop.
Yes.
Okay.
So let me stop sharing here so that we can all see yours. I think we can make you the spotlight so that.
Okay, I'm trying to press it now. Okay, so that I can tap there. Oh, it came on and then I think it went back again. Okay, Professor, this is how it looks like.
Okay, good. Now, I want to see the whole thing. Let me. Okay, don't tell me. Leave it this way. Let me see your first line of your code. Move up, please.
The first line.
Move up. Good. See there. I can see hash include int main system.
Yeah.
STD string name. Okay. STD out. Okay. Move down a little bit. And then move to the right just a little bit. Let me check what is there. And okay, wait a minute. Everything looks clean. Okay. Okay, let me see the last line. Hi, in, comma, you are, move to the right a little bit for me. You are welcome. Move to the right.
Okay.
InfoSource C++, move to the right. Keep going. InfoSource C++ Coding Bootcamp. Keep going to the right. Let me see. STD : NL, STD : the last one. Move to the right again. NL. Let me tell you, your code is perfect. Now, let me see the bottom, the return, where the return is. Let me see where the return is. The return, scroll down. Okay, return 0. I can see that. Beautiful. Okay, let me see the file name, how you save your file. Move to the top Move to the very top. Let me see how the file was saved. The file was saved. Move to the right a little bit. Right a little bit. CPP. Okay. Okay. Now press Ctrl S to save. That dot over there, when you save on your keyboard to save, the dot after welcome.cpp disappear. Good. I mean, I've saved now. Scroll down and let's check the error and let's check what is going on. Please, have you ever run code here before?
No, I haven't run any code with the Visual Studio. This is my first time. Yesterday I missed class, so I was now going through the video to do what you did yesterday, but I wasn't able to finish it. So.
All right. So you've never run any code in Visual Studio Code, right?
No, no.
Okay. But did you test your compiler, see if it's working?
My
when
compiler.
You were installing.
Yes, I test, and I was having problem.
Okay. Please open to command prompt right now, and let's see. Open to command prompt right now. Okay, so I've typed something on the screen. Open to command prompt and type this in the command prompt, and let's see the result. So this is the test.
G++.
Then space dash version.
Dash version.
Yes. So the compiler we are using is called G++. We are using this to check the version we have, and
so based on the result.
Okay, so G++. Okay, good. That means your compiler is installed. All right.
Yes.
So, all right. So please go back to Visual Studio Code and run it and see. Run it again.
Okay, Prof. I'm doing it now. Okay.
Yes. Move to the far right, top right. You see the run icon there, and you click on it. Let me see how the run icon looks like. Move to the top right. Top right, not top left.
Yeah,
top
it has. Top right. Yes, it has come now. It says, "What's your name?"
So it's working.
It's working. Yes.
Then you have no problem. Thank you for sharing.
I don't know why I was getting the error. That's
because
why.
we are with you in spirit, so it's working.
Thank you, Prof. Have a good evening.
All right. So actually let's build a project in class. After my presentation, I'm going to share my screen here and let you see the project we'll be working on. And after the project work, we are going to see everyone's screen and see what they've done. So I want to explain to you that this course is divided into 4 modules. We have module 1, which will run from week 1 to week 3. Then we have module 2, which will run from week 4 to week 6. Then module 3 will run from week 7 to week 10. And module 4 will run from week 11 to week 14. Remember, coding bootcamps, full bootcamps take 14 weeks. And that is what we are also doing here. At the end of each module, we are going to work on a project. So project 1 is going to be calculator. And so we are going to build a console calculator. So by the 3rd week, we'll be done with our project. So in the morning class, they are seriously working on their project. Then the last day of module 1, we'll be taking an examination. There will be a link that will be shared and the questions will be live online. You answer and submit your answers. After that, we move to 2. We are going to build a graphical user interface app. And the app we are going to build is just like Notepad. If you have used Notepad before, we are going to build our own version of Notepad that is going to work. Module 3, we are going to build a web browser just like Chrome. If you've heard of Google Chrome, we are going to develop our own Google Chrome. Then module 4, we are going to develop a media player, just like VLC media player. Those are all graphical user interface. We don't always write software in the console. We use a console to learn the language, but after we learn the language, we use the graphical interface to develop our apps. So that's what is going to happen. And today is just day 3. We have looked at high level, low level. And over here, we have the outline for module 1. At the end of module 1, we are going to bring the outline for module 2. So today is just day 3. You can see that we've learned about low level and high level languages. Tomorrow, we are going to learn about compilers and translators. Today, we talked about compilers, but we are going to really learn about them tomorrow. Then day 5, we are going to start C++ itself. So from day 1 to day 4 are just the basics of programming in general. Day 5 will be C++ itself. Day 6 will be header files and namespaces. Day 7 will start our project 1. So next Sunday, our project 1 begins. If you've never developed a software before, Sunday, we are starting our first ever full or complete software. So you don't want to miss that. Sunday, we all be here writing software, and we will develop a full-fledged computer software. And day 8, we'll continue learning. Day 9 up to day 15. In the last week, we are going to focus more on our software and complete it and write our examination. So this brings me to the end of my presentation. Sorry for taking some few minutes of your time. I hand over to Brother Peddy to continue. So those who have questions should ask him and he will direct the answer. So thank you all very much. Brother Peddy, over to you.
Thank you, Prof. And so it's getting better and better every second and every minute. The professor just shared the model outline to us, and you could see that we are not joking, cry. And so this thing is working. Make sure you are part of it fully. And then by the time you also get to week 3, which the morning session has gotten into, you really feel that you are in the coding world. I told Professor at a point that I now feel that I can code for Amazon. I can code for, all the big computer shots you can have there, So quickly, let's take the few questions. I see 2 hands, so let's receive Peter first, and then we would go on to receive Muntari. So Peter, please unmute yourself and you can talk to us.
Okay. My question was, when he was speaking, when the professor was speaking, it was like, when you enter the instruction, the function, and it will be going out so that the user would enter the name then something. I was kind of confused. I thought this was interaction between you personally and the computer. So I don't know where he's heading to when he says when it goes to the user. I don't understand if you get what I'm saying.
Okay, Brother Peter, I get you very
well.
Yes. So you realize there was a C out and there was a C in. Now for the C out, It means that you are displaying that to the user. You display that to the user to read. Let's say when you get to an ATM machine, it comes, the display is insert your card. After inserting your card, enter your PIN. So that's our C out. You are displaying what the user would have to enter, or the instruction the user would take. Then the C in gives the opportunity to the user to enter whatever was required of the person. So realize the C out was enter your name. Then C in, you now enter that name you were asked to enter. Then the computer now saves in the variable, which is like a container for it. I don't know if that makes sense, but Professor could clarify better if you. Professor, so let's have you talk to Peter some more. Hello, Professor.
All right, so Brother Peter, I believe you can see my screen, and the
Yes.
question, I really understand your question. Over here, we use the cout to display an instruction. And this cout here is actually communicating with the user of our software. Remember, anytime you create software, people are going to use the software. So this instruction says, what is your name? So the instruction will be there for the user to understand what is expected of him. Then this cin, anytime you use this cin, the cursor will start blinking on the console to receive an input. So what this means is that when the user enters any information, the cin will collect that information and push it into a variable and save it. So it will be saved here. So whenever we want to use it, we'll just call the variable. So over here, you can see that we call the variable here. Let me ask the user a question without any instruction. So here, I'm just using cin. Let me save it and run it. So let's see what will happen. There's no instruction. Watch what will happen. So now there's a black screen and the cursor is just there. Okay, wait a minute. What do you want me to type? I don't know. Maybe you want my name. Now I've typed my name, but does it make sense to anyone? Enter. Hi, Darlington. Welcome to InfoSource C Bootcamp. All right. So even though I was able to type my name, I don't think any other person will know that they are expected to enter their name or their PIN code or whatever is expected. And so to do that, you can just write a cout that will make sense. So I can say, what is your name? Once I do this, this will display first before the blinking. Now, over here, I didn't put NL. If I bring NL, watch what will happen. When the person is asked to enter their name, watch what will happen. They cannot type their name next to the instruction. They'll have to type their name at the bottom. So even if you try typing next to it, it's not going to work. So if you like the user to enter at the bottom here, then you bring your ender, but I don't like it this way. I want the user to type their name next to the instruction. So anytime I know I'm about to use cin, I will not use endel. I'll just bring my semicolon without endel. So when I save this and I run, I'm going to see that it's going to ask me, and the cursor will be next to the instruction. What is your name? I can now enter my name and it will work well. I believe it makes sense to you now. Does it make sense to you? Please, do you understand now?
Brother Peter, we can't hear you. Please, are you okay with the explanation now?
Kind of.
Kind of. Wow.
What I was what I was trying to say was that this we are doing is not that we are doing it to spoil it. Oh, come on. Now reconnect. Okay, so what I was saying was that this we are doing. Hello.
Hello, we can hear you, just that your line has been breaking.
Do you hear me now?
Yes, we can hear you.
Hello.
We can hear you, Brother Peter.
Oh.
Okay, so I think the network is disturbing Brother Peter. Brother Peter, please, if you can hear us, maybe please use the chat, okay? Maybe send us the information on the chat. We could still address that. Or better still, after the meeting, we could handle it in the WhatsApp group. Thank you very much. I see another hand. Time is fast spent, but let's take that last hand and then we can we can proceed. So Muntari, Brother Muntari, please unmute yourself and talk to us.
Brother Pedro, mine isn't a question though, but it's more or less like that of Mary's. I also had an error whilst trying to run my code, and then my colors is not as compared to that of professors. I'm seeing different colors on my screen, and I'm seeing different colors on professors' screens as well.
All right.
Okay, would you want to share?
Are you using Visual Studio? Yep. Just press Control S, save it. Okay. Okay. That's
Hello?
Please run it again and let's see.
I should delete and then run again.
No, don't delete.
Oh, fuck. I've
Now
already.
you see an arrow.
I've.
Okay.
And this is what appeared.
Okay, so move your phone closer to the error message and.
Is it I should move it closer to
the error message and let it be a little clearer so that I see it well.
Okay.
So okay, so welcome to CPP 17. There's something on line 17. Let me see your line 17. Okay, you made a mistake. That curly brace is supposed to be one, not an open. Your curly brace one. Good.
Hello?
Yeah, run it again. Save first. Save and run. Yes, save it and run it. Don't save as. Save as. Cancel. Just click on save. Run it. Right. Top right. Click on it. Run the code. Okay. All right. So, your first year 10. Your first year. After the boot camp, we don't need another quotation before the /n. So that thing, just clear it. That quotation in the middle there, before the first slash, is wrong. If you write code and you have errors in it, it won't work. Press space bar. Space once. Just space once. That's okay. Let me check again. The next line, on line 14. Let me see line 14 very well. Move to the right. Move to the of line 14. Okay, so over here, I can see after the bootcamp, you have another quotation. The exclamation should be before the quotation. So wait, clear that and let the quotation be after the exclamation. And then you need your left shift operator in before the endl. Move to the right a little, please. Move to the right. The left shift operator, the less than. Press space first, then the less than. Less than. The left shift operator, bring it exactly. Now, the last thing I want you to do, go to where the file is. File. But don't click. There's an icon down there. Click on that icon. That one, click on it. No, not the search one. No, the left one, the top left. Left, go to the left, up. Good, click on that. Good. Save your work. Let's see. Click on file, save, and run. Run it. It should work. It's compiling now, and you see that it's working.
Yes,
so let me tell you, when you are coding and there are errors in your code, it will never compile. It will never work. So anytime your code fails, the very first thing to do is to look for errors. Look at the error message and get clues from the error message, or go through your code again, because even if there is a small error, it's not going to work. If you miss a semicolon, it's not going to work. So keep this in mind. We call this process debug. So anytime there are bugs in your code, you need to debug it.
Oh, okay.
Don't try to give your code to someone the moment you see that something is not working. That's not how programmers treat errors. When you see an error, study your code again carefully and look for a mistake somewhere. You only give your code to someone to help if you have done everything possible. So this goes to everyone. When you get errors, try and find out where the error is coming from and fix it. So like this, the error was just in the code. So go through the code again, compare it with mine, make sure everything is 100% the same. Even if there's some a 1% error, is going to fail. So let's keep this in mind, and that will help us. Thank you very much.
All right, thank you so much, Professor. I think we are 32 minutes away from our 8 o'clock stoppage time. Thank you so much for holding on until this time. Tomorrow, same time, 7 p.m. to 8 p.m., we will be here to continue coding. Once it's working, we can only push it further to make it even better. Don't forget one of the quotes Professor gave you yesterday: to get to the top, you need to go through some processes. And so we are going through the meal, and definitely will be refined. And after that refined state, we can now travel the world over as great programmers. And so thank you very much. We are in the free week, and then we'll be launching into the paid week from next week. It will be prepaid. Once you do that payment, you'll be migrated to a Telegram page where other tech supports and every other thing will be shared. Now, once we end in the WhatsApp group, as well as the link to today's video. And so make sure you get all of these resources, and then you help yourself in practicing. So thank you very much, Professor. If you have a word again, let's receive you, and then we'll be out of here.
All right, so thank you for joining tonight's class. Again, programming is a process. I don't want you to miss any of the lectures, because when you start missing classes, it's going to start becoming difficult. So make sure you make it a point. 1 hour a day for the next 3 months is going to change your life. So please don't miss this for anything. If you've been longing to understand programming, this is a time. The time is here. The time is now. Let's all work together and let's do this. Have a wonderful evening, and God bless you.
The time is here. The time is now. Have a wonderful evening. God bless you. This is the final words of Professor. And so from me as well, good night. Let's meet tomorrow, 7 p.m. Bye-bye.